for the kind invitation. Time and BPM is the topic of my talk. As I saw from the list of participants here, I have the impression that I'm speaking a little bit to the choir. So it means I think most of you have already some knowledge about time and BPM. And I think I present you my view, and in particular then a list of topics which I think we should work on. And we started on some of them already working. So I would like to start with a very old screenshot, a historical screenshot. You see here is a date. This is a work list. I apologize for the German. We implemented at that time one of the first workflow management system. It was the first one where the workflow client was fully embedded into a browser. You see that browser was Netscape at that time. And we did it for a company, people of my generation still know it was called Digital Equipment Corporation, and Alta Vista was one of the first search engines on the work. So it was embedded here. And we designed a workflow system, and then we designed the work list, and we had here a process, a certain activity, some subject documents associated with an activity, a date when the activity was entered into a work list, and then a due date. A due date? Gosh, where do we get the due date? We have a process definition, we have a final deadline, but for each activity, how do we know when this activity should be finished in order that the whole process finishes within deadline? So that got us puzzled, and that got us in the year of 1997 into the work of time and business process management. Okay? When I showed these slides to my students, they said, gosh, I was not even born at that time. Okay, so you see, time flies, and we have to see that the topic, we have a lot of achievements. I will try to point out the problem involved with time and business process management and how it's distinguished from other management of temporal aspects. In this talk, I want to point out some of the challenges I see ahead. Now, some words about business process management. Well, you see business processes everywhere. It was in the 80s of the last century that there was a huge revolution in business administration, and it said, well, we should look at organizations as dynamic phenomena, and we should consider the end-to-end process, and there were some revolutionary concepts. But the treatment of organizations as entities performing processes was a new vision at that time. And with IT technology, we could support these business processes. And you find them from universities to insurances to banks to productions to stock exchange. Everywhere you find processes. What we are talking here about is process management and not just process enactment. So building a workflow system which runs a process description is process enactment. Process management comprises more. Management is about planning, organizing, leading. It's about making decisions. Okay? And who should make these decisions? Well, there are process designers, process managers, and of course the process participants. So the process participants, if you remember the work list screen I showed you, one of their most important decisions is on which activity, which item in my work list should I work next. Okay. Now, let's see what business processes are. For the management of processes, so for these decisions made, there is a set of key performance indicators which are usually taken. Now, these are the key performance indicators associated with time. And what we are typically interested is, what is the turnaround time of processes? So how long does it take from end to end? What is the throughput? So how many process instances do we get? Another thing is capacity utilization. So we would like to have our capacity generated in a way that it's best utilized. Some more detailed key performance indicators are typically number of time failures, and also the percentage of processes finished within a deadline, or also the tardiness of process instances. It means what is the distribution of deadline misses. How long after the deadline are processes finished? You know, there are processes which are still valuable if they finish after the deadline, and there are processes which are completely wasted. So if you have the process of submitting a project to the European Union, if you try to submit after the deadline, you know, it's not accepted. So the deadline is hard, and then there are soft deadlines. And so there are a lot of things to consider. BPMN is now the standard for modeling business processes. It's a business process modeling notation. And here you see an example of such a business process. Here it is a treatment process dealing with patients and surgeries and so forth. So we have activities, we have dependencies between activities, here precedent sequences of activities, we have decisions, we have parallel, which we don't have in this example here. We have data coming into the process, going out of the process, and we have a start and an end of a process. So this is it in a nutshell. Okay, and now we add time to such a business process. The first thing is we add durations. Durations to activities, so how long does two activity take place, and this is a minimum and a maximum duration, and they can be contingent or non-contingent, so we can control the duration, or we can only observe it. Now, what is contingent or non-contingent, I also call them descriptive or prescriptive temporal constraints, is the following. A prescriptive temporal constraint is something which we have to achieve, and descriptive tells us something about the environment. So, for example, if you do a money transfer in the European Union, it lasts between 1 and 4 days. For us, doing some business, this is a descriptive process. We know this activity takes 1 to 4 days. For the banks, it is a prescriptive constraint because it tells them which constraint they have to fulfill. Okay, now we have durations. What else do we have? We have temporal constraints of any kind. This means we can place constraints between the time points of some events of the process, like minimum time lap between two events or maximum time lap. We have deadlines, which is a certain form of constraints. And with all this, we have to deal. So now this is for process designers, as I have to represent the temporal aspects of processes like durations, deadlines, uncontrollable uncertainties, obligations, and so forth. I already told you about descriptive and prescriptive constraints, and what for process designers is important, they have to check the design for correctness. Now there are different correctness criteria. I will talk about some a little bit later, but essentially what process designers need to know is it possible to execute the process without any time failures? And more strongly is, can we guarantee that with all the control possibilities we have, that there will be no time failure? Okay, and this is also the input for the process designer to do process optimization, so to design the process in a way that it performs better in the key performance indicators. Now, process managers, those are those people responsible for the actual running of the processes at runtime, and so they need decision support and they need policies for, you know, the internal deadlines. I showed you on the small work list screen about slack distribution, about role resolution, so who should do a particular job, capacity planning. So, for example, if things get tight, the process managers could order overtime. They could do exception handling. So, what could exception handling mean? Well, replace activities by faster but probably more expensive processes, drop some things which are not necessary. They do escalation. It means they are responsible if some exceptions occur. And they also talk about acceptance of additional processes. So, and the question is, how can we provide them with the information they need to make these decisions? And again, the screenshot for workflow participants, the most important decision is on which of these activities in my to-do list should I work next? And when should I finish some activities? Can I accept another obligation? How long will the task take? What are the consequences when I'm late? And so forth. Okay. So this is what means to make to do process management, to provide the designers, the managers, and the participants with the proper information for making good decisions. Now, usually then I'm asked, isn't that like production scheduling? And there is tons of literature on production scheduling. Now, the most important differences are the following. Production scheduling is about that. Okay? So production scheduling is about machines, it's about material flow, it's about work prescriptions. Business process management is more like this. It means we don't have so much information about what it takes to perform a job. You see here people chatting. To do an activity, you probably have to phone somebody or have to get some other information. If it could be automated, if you know everything, then we would back here, it means we would automate it. We wouldn't have people in it. Business process management is about involving people, and this we involve people because we don't know everything. So this is the and the other thing is they don't get tired. Okay, they don't want to say, well, I had a very difficult job now, so in the next hour I do something less difficult. They don't say, well, it is almost 6 o'clock, so I only do some minor job today and do the other things tomorrow. So these people want to organize their work. They know also about work things which the system does not know. And another more technical difference is when you start building a car out of these 5,000 variants, when you start producing the car, already the color of the chassis is fixed. You don't make decisions while the car is produced. While here, you make decisions depending on the process state, depending on earlier steps all the while. Okay, so these are the major differences, and this is why we cannot simply apply. And those people here, they would really don't like if they are treated like robots and get a schedule from the system like robots do. So what is the state of the art? Now, as I told you, we are more than 20 years into time and BPM. Well, we have elaborated techniques for representing temporal aspects. I showed you already some time patterns to make things quite clear here. We have elaborated techniques for representing temporal constraints, in particular the temporal constraint networks, and I see in the participant list several people who heavily contributed to the establishment of suitable temporal constraint networks, elaborated notions of temporal correctness. So what we said that the designer has to check controllability, dynamic controllability. It's clear that satisfiability is too weak. In the course of the years, you saw a lot of papers here in the Time Symposium dealing exactly with these aspects. And we have effective reasoning techniques. We have complexity results for checking the correctness. And surprisingly, in recent years, there was still a lot of progress in finding more effective reasoning techniques. Okay, so this is an overview of time patterns. So you see time patterns are patterns where you can model, formulate different temporal constraint, temporal aspects of process execution, like time lags between activities, duration, time lags between events, fixed states, schedule restriction, and so forth. We have temporal constraint networks. So here you have, hi Matteo, there is a whole slew of different temporal constraint networks allowing to express different aspects, in particular different uncertainties. Here you see an example of this STNU, and what we are able to do is, if we have a process definition in, for example, in BPM, we have these time patterns, we can map that to one of these types of temporal constraint networks. And what we then can do is we can apply reasoning. Here, for example, the new rule for STNU, we have for CSTNUs, for all the different things, we have reasoning techniques. We understand the complexity, and this is a great achievement of what, in particular, the time community contributed, and which we can use for our purposes of checking process designs in business process management. However, if I look at the state of practice of the application, there is a question: why is there no widespread adoption of these advanced techniques? There are no standards yet. There are no unified approaches where you see that these techniques are applied in current state-of-the-art business process management systems. Okay. The advancements in temporal representation, so the advancements in all which was presented here at the Time Symposium are still insufficiently considered in the field of business process management. For an example, if you read papers in BPM about monitoring, so predictive monitoring means that you get an idea what is the state of the process and can you finish in time, and when will you finish, etc. You frequently see that satisfiability is used rather than controllability. Last year I read a paper which said, well, we have a robust situation if there is not only one path satisfiable, but there are at least two paths satisfiable. This is rather poor if you consider about the elaborated concepts of the different degrees of controllability developed in the temporal reasoning field. We have no integrated design tools, so I couldn't point you to a design tool where you can design your BPM products and the temporal aspects and run all these checks and get supported runtime. So after these 20 years, there's still a lot to do. So what are roadblocks? So I think one of of the roadblocks is that the formalisms developed here are, for process designers, for practitioners, quite complex. This is an observation we had also with other aspects of business process management. You know, there is a formalism called Petri nets, and there is a formalism which is colored times Petri nets. Wonderful formalism for expressing complex processes. They were not adopted because they were considered too complex, too formal by the people doing the process management. Okay. On the other hand, they accepted and promoted a language like BPMN, which is a horror of a language, with started with quite unclear semantics, has a lot of different features which are rarely used, but well, the industry voted with the feet and kicked out other competing proposals. Well, it is up to historian to find out why that is so. Okay. Sometimes with these techniques, we are also missing a focus on supporting the design process. What does it mean? For example, our checks for controllability. They tell you, okay, this process is controllable, or no, it is not. It does not support the designer to make it controllable. It does not the designer to support, well, do it in this way. These were the constraints which are responsible that it is not controllable. We get a yes/no answer. There is a lack of support for popular process constructs. One of them is loops. Okay, I will come to that later, but the problem is, if you have an unbounded loop, it's not controllable. Full stop. So now loops are not that uncommon in business processes. You find them anywhere. Okay, so we have partial solutions. Then the focus of the time community frequently is on complexity rather than applicability in the real world. What does that mean? Well, I admire the complexity results of all these reasoning techniques and wonderful proofs. However, frequently, then if something is exponential, you stop talking about it. Okay, here we need a little bit more consideration of parameterized complexity. So if I see something is exponential, but it is exponential in the number of sequences of XOR splits. And we know that up to 20 in a sequence, we still can handle it at design time with reasonable, in reasonable time. And the number of XOR splits in practical business processes, which are in sequence, so making decisions, 10 is already a large number. Then even if it's an NP-complete problem, we still might find sufficient support for designers to deal with this notion. And the last point where I think we still have room for improvement is the interrelation between time and other process aspects. For example, time and cost. We came to it, we wrote a system which at runtime, if the monitoring component said, well, you will be late, you did some intervention, and one of the intervention is replace slow activities with faster ones. And the question was, well, why don't we start with the faster ones? And I said, yeah, well, yeah, okay. Because they are more expensive? Yeah, but how do you know? Okay. So it means it makes this intervention only makes sense if there is a cost aspect involved, and now then you have a different dimension. Okay, so with this assessment, I now come to the challenges. If you want a call for, I wouldn't like to call it a call for arms, but a call of help, where we still have challenges which might overcome the current restriction of the adoption of advanced temporal representation and reasoning techniques in the area of business process management. The first is advanced control structures. So here I show you the wallpaper, I call it, of BPMN. It's not just a poster, and you see here all these different constructs. Well, if you like more, let's say, modern design and Cartesian thinking, you might find that overwhelming. Me too. Okay, so but it is the real world, and there are numerous control constructs, and we have to roll it out to all of them. And one is, in particular, loops are under the spotlight, because I think the missing support of loops is one of the major roadblocks. What does it mean? Look here, we have a loop, and as soon as we have this loop, we are not controllable. And this means we tell the designers, if you have a process with a loop, you cannot apply our techniques. And this is somehow insufficient, okay? Because designers will tell you, well, almost all of my processes have some loop somewhere. And then you have to tell them, well, you have to bound the loop, then we can tell you something. I said, no, how to bind the loop? I don't know. For example, when you do a submission of a project to a European research program, you can submit as often as you like, but not after the deadline. Okay, so you don't have a bound, you only have temporal bounds. And this is probably one of the solutions that we add temporal control structures to our process definitions. But we have to really attack the loops. Another challenge is temporal data. Currently, we are focused on the timestamp of events. So of those things which appear in our process models in form of control structures. However, a lot of the data of time information comes from outside of the scope of our process. It's communicated via data. Okay, we have data versions, we have history of data. We have to deal with temporal data in our process model, and we have to study the interconnections between the control structures, the temporal constraints on control structures, and temporal constraints on data, which is probably used also in these control structures. Marco, by the way, is defending his thesis next week, which deals with data of type time. Challenges. Well, one of the challenges are conflicting requirements. Okay, so a process designer is usually not free in the design. He has some degrees of freedom, but the requirements for the process typically come from somewhere else. And there you will find that designing a process also means conflict resolution. And this means that we have to support the designers in the detection of conflicts and with helping them to resolve the conflicts. We cannot automatically resolve the conflicts typically, but we can support by pointing out which are the critical points, which are possible solutions, where are trade-offs between different requirements. Okay. I already told you about prescriptive and descriptive requirements. So what is it that we get guaranteed from our from other process parties? What are our goals? Can we achieve our goals? Can we trade off descriptive and prescriptive requirements? Okay. For example, when you design the process of building a house, the question is, what degree of freedom do you give to some companies when they perform certain things, when they deliver certain things? The more freedom they have, probably influences the price. On the other hand, it influences the time you need people at the construction site and so forth. So what we need here is a support of the process design process. So we have to see that designing a process is itself a process, and the designer has a difficult job to do, and we have to support this process. We have to understand how designers work, and we have to assist the designers in getting in receiving good designs, in checking the requirements and in fulfilling the requirements. Having simply a tool which tells you yes or no, correct or not correct, is simply not enough in that respect. Another challenge is runtime support. So most of what we did up to now is mainly concerning the design time. At runtime, one of the things is detection of exception and exception handling. Well, this is done by current system. If you have temporal restrictions, you can have a process enactment service to check these restrictions and to throw an exception if a deadline, if a time constraint is missed. We have exception handling and escalations. When we talk about predictive process monitoring, I still see that here in predictive process monitoring, the typical situation, the typical procedures used and formalisms used are still rather satisfiability than controllability. We need predictive process monitoring to come to a proactive time management. It means supporting the management in a way that we do not detect time failures, but we avoid time failures by controlling the process. What the challenge is for runtime support is that we need algorithms with lower complexity. We can help with pre-computations, but we have to look that we need different approaches for design time and for the runtime. In the runtime, we have a huge number of process instances, and we don't have as much time for computing our results than we have at design time. In particular, pre-computing in this age where memory is almost for free is one of the ideas, but that also hits a lot of now not time complexity barriers, but space complexity barriers. So dealing with space complexity and time complexity in a way to do design time calculations which still deliver acceptable amounts of data for making runtime computations more efficient is, I think, an open research problem. Now, one of the things we are also looking into, and I think are necessary, is a notion which I call probabilistic controllability. So This means we treat controllability not as a binary property. Currently, controllability is a yes-no thing. In the real world, we take risks. Okay, we prepare papers to submit for a conference, and we start writing the paper even if we are not 100% sure that we will meet the deadline. We don't go to the airport the day before and camp there because once in a year there is a huge traffic jam and there is an accident on the highway and we miss our flight. Okay, so it means we take risks, and what we would like to do is we don't want to be told yes, it is possible that that you will miss your flight. What we would like to do is to make a rational decision. So, for example, if I schedule my way to the train station to risk the train, it's sufficient that let's say I have a 10% chance of missing the train, so I have a 90% chance of being on time. Why? Because the next train is in 1 or 2 hours. Okay. I wouldn't like to take the same risk for missing a flight, because if I miss the flight, you know, this is very expensive and I probably have to cancel the meeting because the next flight is the next day and I have to spend a lot of money. Okay, so it means we deal with risks. We want to know what is the probability that we miss a certain deadline, that we violate a certain temporal constraint. Okay. Why do we need probability here? Well, we have probabilistic uncertainty. Now, for durations, we typically deal with a minimum and a maximum duration. However, in reality, there is some kind of a distribution function, and that can be very different. So we frequently find this long tail. So usually I go to the airport in 15 minutes. But if there is a traffic jam and they close the tunnel, it may take up to half an hour. Okay? So you see, I live in a small city. Okay? So should I always consider it could take half an hour or even an hour once a year? Okay, usually not. Here we have a different distribution function. So we have distribution functions for durations, and we have branching probabilities at XOR splits. So here there is a check, and from statistics we know that in 85% of the cases it is a no, and only in 10% of the cases it is a yes. Okay, now this changes, of course, the typical duration of the whole process. Now, if we have that, what we can do is we can define probabilistic controllability as a way of talking about the risk to miss a particular deadline, to violate a particular constraint, or the general probability of a time failure in the execution of a process. Okay. This is a rather challenging part of research. We are looking into it, and we invite everybody to join in that. But I think it's really needed. Another challenge is time and other dimensions of processes. So one is cost, another is risk awareness with the probabilities. To tell you a little bit about time versus cost is the cost of an activity may depend on its execution time. So it might be increasing with execution time, it might be decreasing. So if you rent some machinery, then typically you pay for the duration, and the longer you need it, the more you pay. If you select the shipment for some goods, typically the shorter it takes, the more it costs. Okay? And now we have a question on the process. I give you the duration of a process because I need to have the process finished by some deadline. How much does it cost? And if I have a certain budget, I can ask you how long does it take, minimum or maximum, okay, to meet that budget. Okay, so we see that we frequently have here antagonists, and we can have both increasing and decreasing cost in the same process. And there are a lot of interesting calculations you can do with that. But for time, we need also other dimensions, antagonists, in order to make rational decisions. So this leads to my conclusion. Time and BPM has come a long way. They are different research fields. This is sometimes you might have thought that I have a strange accent for somebody working in the time field. There is the formal dimension and there is the application dimension, and I think in these temporal aspects of business process management, the two have come together, and I think this time symposium is a great way of communicating it. And we are some people who try to bridge this gap between the business process management area and the more formal temporal representation area. And I tried to point out some of the challenges I see that where I see requirements from the area of business process management, where we don't yet have the right tools from temporal representation and reasoning in order to develop systems that solve these requirements in the business process management area. Thanks for your kind attention.
Thanks a lot. So now the participants can unmute themselves and make questions. We also have a...
May I start with a question?
Yes.
Okay, thanks. First of all, congratulations, Johann, for the presentation. It confirms me in continuing to work on research in temporal constraints and business process, because there is a lot of things to do and a lot of research direction to investigate. I would ask you some details about the distinction between descriptive versus prescriptive constraints versus the other contingent and non-contingent distinctions. So what are the relationships between these concepts?
But in a first attempt, you can translate descriptive to contingent durations and prescriptive to non-contingent. It goes if it not only the problem here is also with the notion. We now decided that in the future we will call about controllable and non-controllable durations, because people get confused all the time. Now here the notion of descriptive and prescriptive goes beyond durations. For durations, you can translate it directly into contingent and non-contingent, but you have other constraints. Because, for example, for the bank, you know, it's not the duration of a single activity, but it is an upper bound constraint on a whole process, because there are a lot of steps in order to make a money transfer, okay? And so we have to extend this notion of contingent, non-contingent to other constraints as well. So this is one motivation, and the other is to make it clear to designers what are you can work on the prescriptive in a limited way, and you can work on the descriptive in a limited way. Typically, those are parts of negotiations, of communications between parties. So we considered it best to consider it as descriptive and prescriptive, things which I have to fulfill, and things I can get as guarantees from others, which I can rely on.
Okay. Thanks, Johann.
Further questions?
I have.
May I?
So I was interested in the stuff you said around slide 21, 22, and you were talking about there was some formalized, I think it was to do with Petri nets that people didn't adopt, and the community had some horrible language that they did not adopt or propose, I think it was. Isn't there a problem with some of the things you're trying to do that maybe the community will reject them for the same reasons? So yeah, have you considered going to the community and seeing what they actually want, and whether and how the front end should be shown to them? I mean, it might be Petronets underneath or any other thing that's been suggested, but how they want it showing to them to make sure they adopt all these things that sound fantastic rather than it just gets left on the shelf. So human factors is the question.
Yeah, it is a human factors, and you see, it is a very broad field, and a lot of these decisions is not made by computer scientists, but by business administrators, and BPMN started as a drawing tool, but it was adopted by so many process managers that it caught on, and now it's executable, and now it's the intergalactic standards for designing business processes. And if you work in the area, you know, there was not a particular decision made by some community. It was you know, as I said, they voted with their feet. People adopted it and found that, well, we want to express that, it's not possible so easily, so we invent a new construct to make it, to represent it, and this is how these languages grow. And you know, we know a lot of languages which were developed in this way, and but you know, there were people trying to tell them, you know, this is not so good, we don't have a clear semantics of the constructs. They didn't listen.
Isn't this a worry for you and your team, though, that all your hard work that might turn up something beautiful will go to waste?
No, well, what we try to do is we develop solutions, we try to embed it, and well, let's put it that way. If we at least can support a core part of BPMN and tell designers, well, if you stick to these well understood constructs, you can use all the others, then we cannot help you. But if you stick to those where we know the semantics precisely, we can help you and we can assist you. We can do some checks and calculations, etc. But we have to be aware that, for example, some things are essential, and this is what I pointed out with the example of loops. They are really essential. And if we don't have a way of supporting those and dealing with those, they will send us back to do our homework.
Okay, thank you.
We had one more question before.
Maybe a comment on loops. So thanks for the great presentation. So you basically before show an example in which an unbounded loops could be solved by a deadline, and basically is one of the way of having a solution to solve these loops. And it's interesting because from an algorithmic point of view, I see it as a problem for controllability, because if the loop is unbounded, putting it under a deadline should break controllability at some point, because you have a deadline. Maybe one of the possible ways to tackle this problem is that of thinking about different kinds of strategy or loops not under a deadline, and in that particular way, maybe we have a strategy which is profoundly and natively cyclic. So until you keep looping and you keep executing everything that is in that loop, the strategy basically repeats. If you go out, you will do something else. So maybe the problem that I see with temporal networks is that they are a formalism, that model processes that they have a well-defined start point and a well-defined end point, but we have never thought about cyclicity in temporal networks. That may be one of the open points, or maybe because it is not the right formalism, and we need something maybe based on automata, on something which is more cyclic by default and works on infinite strings.
Mm-hmm.
And just a comment.
Yes, no, thanks. You're perfectly right. And this is what I wanted to point out, that one of the things of the missing adoption of temporal constraint networks in business process management, in my opinion, is because we don't have a good solution for loops. And we need to come up with some.
Yeah. So one of the possibility is to go for a common effort and putting different backgrounds together.
Yeah.
It will solve the problem.
Yes.
Now Nikolai wants to.
Thank you very much. It is finally my turn. I have three questions. Well, the first is very technical. How to deal constraints when we have time constraints, when we have different, let me say, clocks. Even right now we have lunar calendar and solar calendar. So different agents can have different time measures.
Yeah.
Do you need barriers or something to synchronize process?
Well, I can tell you from experience that what you have is, for example, the problem of weeks versus months. Okay. So that's easier. I know the lunar and the solar calendar, they have a very nice mapping. Weeks and months don't have a very nice mapping. There are techniques how to resolve that. In business process management, we typically don't talk about nanoseconds. So we have rather coarse-grained things because people are involved. So we are talking about minutes or hours or days. And there, the clock synchronization, at least, does not make such a big problem. So it means that our techniques for a difficulty, this is in particular in inter-organizational processes. Okay. Where you exchange, roughly. And there it is that we are able to synchronize the clocks in a way that the time lag, the possible time lag between the clocks is small in comparison to the time units we are typically dealing with. Another thing is the mapping of different calendars. So you have days, you have working days, you have banking holidays, and there are techniques where you need to know, for example, for the duration between 2 calendar days, how many working days can there be in between, or the same in the other way. There, essentially, you do calendar mappings. And you do also a calendar mapping when you instantiate the process. When you know at which date it starts, then you can fix uncertainties. But different calendars, different time zones some might be ironed out if you have a precise mapping, like between solar and lunar, and for some it introduces some kind of uncertainty, like what is the number of working days between 2 calendar days. If you take Christmas into account, it can be long.
May I ask one more question?
Sure.
Well, basically, I am happy with your previous answer, because basically, what did you say? Pragmatics. Well, in practice, usually the problem can be resolved quite easily. But this time, question is, well, do you think, does it make sense to try to combine business process BPM with, for example, Simulink language for simulating physical processes?
Simulation is one of the approaches where you can check correctness of process definitions. Okay, so one way, the way favored by the time community is that of having analytical processes. Currently, there are, when it comes to correctness and for computing temporal properties of process definitions, you have 3 approaches. One is the time approach. You apply reasoning rules and temporal logic in order to find out things like controllability, etc. The second approach is simulation. It means you run a lot of simulations and do a statistics of the result, and then you see whether you get time failures or not. And the third now is process mining. It means you don't do simulations, but you analyze the logs of all the running processes. Some people, when I come with our in the BPM area, when I come with our techniques for calculating things like controllability, say, well, we don't need that, we have process mining. And I tell them this is like, you know, building the train schedule by observing how many train wrecks you have per week. So it means there are applications where you need to do where you have new processes, where you have a huge number of different process variants, where you need analytical techniques, and where you don't have enough instances, in particular in dynamic environments. But simulation is a way of trying to ascertain things. It means that if simulations become cheaper than doing the reasoning, it is another approach for checking it. But reasoning has the advantage that it gives you guarantees. Simulation only gives you evidence. There is a difference. So if we can solve it with analytical measures, with reasoning techniques, in my opinion, it is preferable. But, you know,
thank you.
Thanks a lot, Johann. Further questions can be